Hi there, myself Albin Babu, and I am working on this project with my teammate Erwin Biju. This is a WCM assignment my team has prepared, and I will explain how my GNU radio flow graph works. This flow graph performs wideband FM demodulation. It reads an RF signal file, shifts it to baseband, filters and demodulates it, and finally outputs a clean audio through the speaker. First of all, uh, the process begins with the file source block. I have loaded an captured RF file provided by the processor and set the output type to complex. Repeat is set to yes, which means the signal will continuously loop so that I can analyze it without restarting the flow graph. And the next one is signal source. It uses the same sampling rate as the file source, 2.4 megasamples per second. The frequency parameter is set to 1 million, which means it helps shift the signal frequency down to baseband for easier processing. Amplitude is 1 with 0 offset and phase. And the multiple block takes the two inputs, the recorded signal and the cosine wave, and multiplies them. This is called mixing and frequency translation, which centers our target FM signal near 0 Hz so the demodulator can work properly. After mixing, I apply a low pass filter to remove unwanted high frequency components. Here the decimation factor is 10, the cutoff frequency is 90 kHz, and the transition width is 10 kHz. I used a Hamming window with a beta value of 6.76. This ensures that only the useful FM channel bandwidth passes through while reducing noise. And next is the power switch block. It helps mute the output when no strong signal is present. I set the threshold to 40 dB, alpha to 100 milliseconds, ramp to 0, and gate to yes. The filtered and squished signal goes to the WFM receive block, which performs the actual FM demodulation. The quadrature rate is set to SAM rate divided by 10, and the audio decimation is 5. This converts the high rate complex signal into an audible audio signal. And next, after demodulation, I use a high pass filter to remove DC offset and very low frequency harm. The sample rate is 100,000, cutoff frequency is 300 Hz, and transition width is 200 Hz. Again, I use a Hamming window. This keeps only the audible frequency clean for playback. Then I include a multiple constant block with the constant of 2.0. This simply increases the audio amplitude, making it louder and easier to hear. The audio sync plays the processed audio through my computer speaker. The sample rate is set to 24 kHz, which is a standard audio rate for clear voice output. OK to the block is set to yes, and it takes one input channel. Also, I added uh, GUI syncs and GTQI time sync to visualize the signal. The GUI frequency sync lets me see the spectrum before the filtering. It uses a Blackman Harris window and a 50 size of 1024. The GUI time sync shows how the amplitude changes over time, helping me confirm the demodulated audio waveform. The GUI range controls lets me tune the frequency interactively between 98 and 102 megahertz. And that's it, a conclusion. So overall, the setup reads an FM recording file, translates it to baseband filters, squelches, and demodulates the signal. Then outputs the final audio while providing real-time spectrum and waveform visualizations. This demonstrates the full process of FM demodulation in GNU radio from RF to clean audio output. And here's our audio output, which is processed. There is no background noises. Any others?
Good job. You've successfully recovered the audio. Now make sure there is no static or noise in the signal. Good job. You've successfully recovered the audio.
Thank you.
Now make sure